Now I have a little update on the CPU, which I should actually call the computer now because we've got a keyboard and a display, and we've got the graphics and we've got the computer separate here. So as of yesterday, I was able to write stuff on the keyboard and have it displayed on this display here. But today what I did was I took the code for reading stuff from the keyboard into the computer, and I called it a get character, and I've generated its own subroutine. So the get character subroutine will now sit in the ROM, and I've also written a little print character routine, and that print character routine also sits in the ROM. So rather than have the program sitting in the RAM as part of the program, these are routines that are going to get used all the time. So we have them sitting separately in the ROM, and we can just use the jump to subroutine and return. And you might even call it a call. So it's a call to a subroutine and a return. And it'll run through the subroutine in the ROM. And then it'll come back to the program, and then it'll run through it'll tell it to run through the other subroutine and that's in the ROM as well. But also today what I was going to do was, if I just do one character at a time, so whenever I type in just a single character here, so a single character H, and whenever the computer's running, I want that character just to display up here. So that's going to be relatively straightforward using what I've done so far today, because all I really need to do is set aside one memory location for one ASCII value for a letter. So it will automatically, whenever the computer starts up, rather than going to the first line of a program, we're kind of entering into a little bit of a kind of operating system here, because rather than jumping to that first position, I'm going to get it to jump to it'll be in a waiting condition. So it'll be waiting for keyboard input. And whenever it receives the keyboard input, it will go to the get character, and it'll also then go to the print character, and it'll print it straight out on the screen. So I'm going to do that automatically. Exactly where I go from that point, I'm unsure, so it's still a bit of a work in progress from this point onwards. But it is getting there, and I'm able to run in some nice little programs. I've also put together my first pass at a game. Now, you remember the game Pong. It's where we've got the two little paddles, one at either side, and the ball bouncing back and forward. So, or just maybe getting it so it hits off just one end, like the wall, and coming back. So I'm making an attempt at that. As it stands now, I've got everything within the assembler that I need in order to generate that. And in fact, today also I put together another option within the assembler, which allows us to read in an entire sentence. So you can write in a sentence in ASCII, and the assembler will take it. You can write in the entire sentence in your language, say English, and the compiler, the assembler, will take it a letter at a time, produce the ASCII, save it to a memory location, and that the first address of that memory location will be associated with that little bit of text. So it's all coming together. Right now, I've kind of passed, or almost passed, the part where we are changing the actual connectivity within the CPU. So there's only little tweaks here and there. And most of what I'm doing just now is really in the realms of computer organization. So I'm trying to organize how the information is passed, between the displays and the graphic card, and it coming in through the keyboard. And an awful lot of that is involved in is not actually changing the circuitry, it's generating some nice assembly language code to help you control all of that process. So that's where I am at the moment. Not a lot to show you here. You'll have access to everyone once I get the final course together, as soon as I possibly can. So thank you for listening. I'll get you in the next video. Goodbye.